Let's start looking now at the application side of systems of equations. We've learned the three methods for solving: graphing, substitution, and elimination. So we're going to put them to work now. We're going to actually look at some word problems that once you've set up your equations, we then have the choice of using substitution or elimination to solve them. So the first and most important thing to do when you are solving a word problem is to read all the way through it from beginning to end without stopping. So you are on a prom decorating committee and are in charge of buying balloons. You want to use both latex and Mylar balloons. The latex balloons cost 10 cents each, and the Mylar balloons cost 50 cents each. You need 125 balloons, and you have $32.50 to spend. How many of each should you buy? Once you've read all the way through a system of equations, the next thing your focus is establishing what your variables represent. Well, if you're familiar, when we have systems of equations, we typically have two variables, x and y. So what we want to decide is, what do these represent for us? The easiest way to decide what they represent is by looking at the question. And the question is typically your last sentence. So our question here is, how many of each should you buy? Well, when I say each, what am I referring to? I'm referring to your balloons. So what type of balloons do we have? We have latex and Mylar. That's what's going to represent your two letters. We want to know how many. So we're talking about the number of balloons. So I'm going to let x be my number of latex balloons. And I'm going to let y be my number of Mylar balloons. That's called establishing your variables. That's something that you need to do when you write an equation, when you write a system of equations, because it's telling me and anybody else who's reading the problem what each variable stands for. The next thing we look for is we look for numbers that have the same type of units. So when I'm going to look through my word problem now, I'm looking for numbers that have similar units. Well, the first number I see is 10 cents. That's a dollar amount. And I see two other dollar amounts. So I'm going to highlight those. I have I have 10 cents, 50 cents, and $32.50. Because those all have the same units involved, they're all going to go in the same equation together. So let's talk about how we write an equation from it. The 10 cents was the cost of the latex balloons, and latex balloons is the letter x. So my equation is going to start off with 0.10x. The next number I see is 50 cents, and 50 cents was Mylar balloons. So then after the 0.10x, I'm going to put 0.50, and y is Mylar, so 0.50y. Now, I'm combining the Mylar and the latex together, so that means I'm going to add them. And the last number I see is $32.50. Well, that's a total amount. Anytime we have totals, totals always go on the right side of the equal sign. So 10 cents for each latex balloon plus 50 cents for each Mylar balloon gives us $32.50. What numbers do we still have left in the word problem? Well, I see one final number. I see 125. Well, 125 doesn't have any other numbers in the word problem to go with it. It's an only number. You need 125 balloons. Well, the question is that latex balloons only? No, it's not. Is it Mylar balloons only? No, it's not. It is the combination of them together. So it is, again, a total. So my second equation, the total, is 125. The problem is, we don't have any other numbers. Well, that's okay. It just means that there isn't numbers in front of X and Y. It is simply the number of Mylar balloons plus the number of latex balloons has got to equal 125. We have just written our first system of equations. Again, look for the numbers that have the same units and put them all in the same equation. At this point, we're ready to use our old skills. I don't care whether you use substitution or elimination. It's whichever you feel more comfortable with. Okay? Graphing is not an option. That's the only one that we're going to rule out. So I'm going to do this first one using elimination. That was the method that we learned the day before. That was where we had to cancel our letters. So it doesn't matter which one we cancel. I'm going to go ahead and cancel the x's to make life easy. Now here's the beautiful thing. One x has a number in front of it, but the other x has nothing in front of it. That gives us the freedom to multiply by whatever we need to make them opposites. So I'm only going to be multiplying the bottom equation by something. And because the top one has a positive 0.10, I need the bottom one to have a negative 0.10. This is actually the easiest kind of problems to do elimination on. So my top equation is not changing. 0.10x plus 0.50y equals 3250. My bottom equation, negative 0.10 times x is negative 0.10x. Negative 0.10 times y is negative 0.10y. And negative 0.10 times 125 is negative 12.50. Do we have opposites? Absolutely. Those two are completely opposites. So if you remember, the next step of the process is to add. So I'm going to draw my big giant line, and I'm going to add down the columns. Well, 0.10 plus negative 0.10, cancel. 0.50 plus negative 0.10 gives me 0.40y. 3250, take away 1250, leaves me with 20. Last step of the solving process, I'm going to divide by 0.40. And I get y equals 50. So what's the next step of the process? We have half of the answers. We know what the y answer is. We need the x answer. Well, the next step of the process is to plug that number back in. So I am always going to plug it into the easier of the equations. And if I look at my two red equations, the bottom one looks much easier. So I'm going to put 50 over here in place of y. So x plus 50 equals 125. Well, that's a very easy equation to solve. I have one number to get rid of. I'm going to subtract 50 from both sides. That leaves me with x equals 75. Now, these are word problems. We are talking about real life stuff here. We are not going to write a pair, because that pair doesn't mean anything to us. We're going to come back up here and we're going to reference our original setup. X was the number of latex balloons. So I'm going to say, I need, X was 75. I need 75 latex balloons. And Y was Mylar, so that's 50, and 50 Mylar balloons. And yes, you are expected to write one sentence that contains your answers. So, that being said, we've gotten through example 1. Let's look at example 2 together. Example 2. For 30 minutes, you do a combination of walking and jogging. At the end of your workout, your pedometer displays a total of 2.5 miles. You know that you walk 0.05 miles per minute and jog 0.1 miles per minute. How many minutes were you walking and jogging? So if you remember from the first example, our first goal is to decide what X and Y represent. Well, look at your question. Your question asks, how many minutes were you walking and jogging? We're focusing on minutes. So, X is going to be the number of minutes. We'll just make the first one walking, which means Y is the number of minutes jogging. Always use that question to establish your variables. Now let's look at an equation. This one's a little more tricky. We have 4 numbers. We're looking for units that match. So I see 0.05 miles per minute, and I see 0.01 miles per minute. Those definitely match. The problem is, the other two have minutes and miles only. So we got to figure out which one is the total for this problem. Let's start the equation now. 0.05 was your walking, which is X. So 0.05X. Your 0.1 was jogging, so plus 0.1Y. So the decision is, what's the total for this equation? And here's the easy answer. If we look at the 0.05 and we look at the 0.1, they have miles and minutes mentioned. Whichever one comes first, which is miles, that's the third number we use. So the third number that has miles is 2.5. So that is my total that I'm going to put over here. My other equation is my remaining number. In that case, that is 30 minutes. Well, the 30 minutes, you are combining walking and jogging. So it is a total. So I'm going to put equals 30 minutes. Now, we don't have any other numbers, but X is the number of minutes walking. So we're taking the number of minutes walking plus Y, which is the number of minutes jogging, and it should total 30 minutes. The minutes I walk plus the minutes I jog should total 30. So at this point you have a choice between the methods. Now, I think a majority of you are probably going to lean towards elimination when you're doing word problems. I can tell you right now, it will make your work the easiest. So let's do elimination one more time, and then we'll do the next one with substitution. What variable would you like to eliminate? That's really your choice. Should we do X again? Sure. Remember, this is easy because we take the equation that has no numbers, which is the bottom one, and we multiply it by the opposite of this guy. So negative 0.05. So let's see what kind of results we get. Top equation not changing. 0.05x plus 0.1y equals 2.5. Let's look at our new bottom equation. Negative 0.05 times x is negative 0.05x. Negative 0.05 times y is negative 0.05y. And in your calculator, negative 0.05 times 30 gives me negative 1.5. Now that we have opposites here, we are ready to add. The opposites cancel. 0.1 minus 0.05 leaves us with positive 0.05y. Let your calculator do all that for you. 2.5, take away 1.5, leaves us with 1. If we divide by 0.05, use your calculator. 1 divided by 0.05 should give you an answer for y of 20. Final step, take the easy equation, that would be this bottom one, put 20 where the y is. So x plus 20 equals 30. Subtract 20 from both sides. We get x equals 10. We are ready to write our sentence. Let's come back up here. X is the minutes walking. So I would start my sentence with, I walked, let's see, X was over here, 10 minutes. And jogged. We're looking for Y for jogging. That would be 20. So I jogged 20 minutes. I'm not asking for a big long sentence. I'm asking for you to simply label the answers in a single sentence. So how are we starting to feel? The hard part really should be writing the equations. Okay? The solving, we've already spent several days on. But the writing equations is the new part. So let's look at one last problem. So example 3. Your portable stereo requires size D batteries. You have $25 to spend on 5 packages of 2 batteries each, and would like to maximize your battery power. Each regular package of batteries costs $4.25, and each alkaline package of batteries costs $5.50 because alkaline batteries last longer. How many packages of each type of battery should you buy? Let's establish our X and our Y. Okay, I'm going to highlight my very last sentence. How many packages of each type of battery should you buy? I am asking you about the number of packages. So my X is going to be the number of packages of, what's the first type? Let's see, it said regular batteries. And my Y is the number of packages of the other type of battery was alkaline. Okay, next step of the process. Start looking for numbers that have similar units. Well, the first thing that pops out to me are a whole bunch of dollar amounts. I see $25. Whoops, let's make that a different color. I see $25. I see $4.25. And I see $5.50. Okay, well, $25 is what you have to spend. That's the total. We'll come back to that one. The next one, $4.25, is your regular batteries. So $4.25 goes with regular, which is X. So 4.25X plus. The next number is $5.50, and that was alkaline. So alkaline is Y, so plus $5.50Y equals, and we already said our total was $25. Okay, what's the only number that we have left? Well, this is where we get tricky. There isn't one number left, there's two numbers left. There's 5 and 2. We only need one of them. The other one is extra. Here's where the decision comes in. The X and the Y are packages. Both of them are. So what number left over is packages? That would be the 5, which means the 2 is a worthless number. It means nothing to us. That being said, let's write our other equation. We're going to use substitution, so I'm going to write them side by side this time. 5 is obviously the total, so I'm going to put equals 5. So I have number of packages of regular, which is X, plus the number of packages of alkaline, which is Y, equals 5. So X plus Y equals 5. Okay. Are we ready to solve? We're going to use substitution, so we're using the other method. We have to pick one of these 4 letters to get by itself. X here, Y here, X here, and Y here. Which ones don't have numbers with them? Well, that would be the second equation. So pick whichever letter you want. We all know you guys prefer Y. Get Y by itself. And that means I'm going to put on my fence, I'm going to subtract X from both sides. That leaves me with Y equals negative 1X, because yes, that is a negative 1, plus 5. We are done with step number 1. Step number 2, connect the dots. Y is by itself here. That means I circle Y over here and I connect them. So we're going to do some substituting. 4.25 stays the same with the X, plus 550 doesn't change, but Y does change. I need parentheses. Instead of Y, I put negative 1X plus 5. Close parentheses, and I keep the equals 25. Okay, so next step of the solving, put your line up the middle. We are ready to distribute. I'm going to keep 4.25x, 550 times negative 1x is negative 550x. In your calculator, 550 times 5, type it in your calculator. I got 27.5 equals, keep the 25. What do we do after we distribute? We always combine like terms. So 4.25x minus 5.50x is negative 1.25x. Keep the positive 27.5. Keep the 25. Then I need to subtract 27.5 from both sides. Keep negative 1.25x. In your calculator, 25 minus 27.5 should leave you with negative 2.5. Final step, divide by negative 1.25. We get x equals, if you type negative 2.5 divided by negative 1.25 in your calculator, you should get a positive 2. So we are ready to finish substitution with another connect the dots. The 2 here, the x here connects with the x over here. So on our paper we have y equals negative 1 times, we got the number 2 for x, plus 5. And if you type negative 1 times 2 plus 5 in your calculator, you get 3. We're done solving. To me, this takes longer than elimination, but that's your choice. Let's look at writing our final sentence. So our sentence starts off with, I need X is packages of regular. So X was 2. I need 2 packages of regular. And Y is packages of alkaline. So that's in 3 packages of alkaline. And we are done with that third example. Those are the problems where you are writing equations and solving. We have one slightly different example just to kind of put your brains thinking a different direction. Let's look at example 4. Example 4 is giving you the equations. We want to write a story that will go with it. So I always make this suggestion that if you're buying stuff, that can sometimes be the easiest way to write a story. So I'm going to think of 2 things that I might want to buy. I'm going to the grocery store, and I love fruit, so I'm going to buy apples and oranges. So I'm going to start my story by saying, I am going to the grocery store to buy fruit. Now, the next easiest way to tackle this is to explain what those numbers mean for each equation. Now, it's easier to figure out a price than it is to figure out an item. So here's what I'm going to let my first sentence represent. I'm going to say that I bought 3 apples and 2 oranges. So X is apples, Y is oranges. Now 11 is going to be the cost. I bought 3 apples and 2 oranges for $11. Yep, those are some expensive pieces of fruit. I'm going to do the exact same concept on the second equation. I also bought 4, now keep X the same, so 4 apples and, well, what's the number in front of Y if there's nothing there? Hopefully we all know it's a 1. So, and 1 orange for, of course, 2 is still money, so for $2. What's the one thing I haven't talked about yet? I haven't talked about how much these items cost. That's what you're trying to figure out. So the question you would then pose is, how much does each apple and each orange cost? And that's all you're doing here, is you're writing a word problem. Now, I don't mind if you guys kind of, when you're doing your homework, especially in one of them, if you use my concept of going to the store to buy stuff. I do not want to see any stories about apples and oranges. I want to see you buying your own items, but you can use the concept. So that being said, we are done with this set of notes. You can start on your homework if you would like. Otherwise, you will have time in class.